You are welcome to GMAETS 41's YouTube channel. In our class today, we are going to give attention to how to prepare a solution of base. In our previous class, I taught you how you can prepare a standard solution of an acid. That, of course, we tagged part 1 of preparation of standard solution of acid and base. So we are going to say, if you are asked to prepare a standard solution of a base, of course, which is expected to be used for, let's say, practical and experiment, how can you go about it? So once again, you're welcome. If you're yet to subscribe to this channel, please right away hit the subscription button. Then go ahead and turn on the notification bell so that whenever I upload any content or come on live, you will be the first person to be notified, so that you won't miss out. Now we are going to describe how we can prepare a 0.1 molar solution of a base. The base we are going to use is potassium hydroxide. If you're dealing with a base, right? Bases, usually if you go to a chemical shop to buy it, you get them basically in solid form. They come in pellet form. So you are required to actually get the base and dissolve it in a given volume of distilled water, and of course get whatever concentration of the base that you are required to prepare. So like I said, we shall be describing how to prepare a 0.1 molar solution of potassium hydroxide in 500 cubic centimeter of a volumetric flask. So what is the first thing that a student is expected to know? The first thing is to determine, which of course is the first step, determine the mass. I repeat, the mass of potassium hydroxide that needs to be weighed and dissolved in the given volume of solution, 500 cm cube. Now, how do you determine this mass? It's just like in the case of acid. In our previous class, what you had to determine there was the volume to be diluted. So in the case of base, because it comes in solid form, you determine the mass of the base that needs to be dissolved. Which formula do you need in order to determine the mass of the base that needs to be dissolved? Now, there is this formula given as molar concentration equal to amount or number of moles divided by volume. Now, if the volume is in cubic centimeter, you multiply that formula by 1000. But of course, if the volume is in dm cube, decimeter cube, or in liter, there is no need of multiplying N over V, that is amount over volume. There would be no need to multiply it by 1000. But in our case here, the volume of the volumetric flask is 500 cubic centimeter. So in that formula, concentration C equal to amount N divided by volume V would have to be multiplied by 1000. Now, remember I told you that we have to determine the mass of the potassium hydroxide that needs to be dissolved. In this formula, there is no mass directly. But hey, remember, mass is hidden in number of moles amount. You know that amount N is equal to the mass to be dissolved divided by the molar mass of the substance. Now, if you copy and paste that formula, your concentration is going to be mass over molar mass divided by volume and then times 1000. Now, no time to waste. Let's just work out on this formula and then make mass subject of the formula. If you do so, the mass of the potassium hydroxide to be dissolved is going to be CVM divided by 1000. Once again, the mass to be dissolved M is equal to CVM divided by 1000. The C there is the concentration, which in this case, remember, we are preparing 0.1 mole per dm cube or mole per liter. Simply put, 0.1 molar potassium hydroxide solution. That's what we are preparing. I hope you're following, right? So, that C is the molar concentration. Then V is the volume of the flask. And then that capital M is our molar mass of potassium hydroxide of the base. Then you divide by 1000. If we fix the parameters, the data, the values of these quantities into the formula, then our mass is going to be 0.1 multiplied by the volume 500 times the molar mass. Molar mass of potassium hydroxide, if you work it out, you are going to get 56. All right, because of course it's going to be potassium, which of course is 39, then plus oxygen, which the relative atomic mass is 16, plus hydrogen, which is 1. If you add up 39 plus 16, you get 55, then plus 1, of course you see that you're going to get 56 grams per mole. That is the molar mass. Now divide everything by 1000. If you simplify this, the mass of the potassium hydroxide to be dissolved in this case is 2.8 grams. So the first step has been done, which is to determine the mass of potassium hydroxide to be dissolved. 2.8 grams. Step 2. Weigh 2.8 grams of potassium hydroxide using, of course, a weighing balance. Weigh 2.8 grams of potassium hydroxide. So you need to use a weighing balance and weigh 2.8 grams, because that is the mass of potassium hydroxide in the case of preparing 0.1 molar potassium hydroxide in 500 cubic centimeter. So you have to weigh this mass that you have determined, that you have calculated. That is step 2. Let us move on to step 3. In step 3, dissolve the 2.8 gram mass of potassium hydroxide in about 200 cubic centimeter of distilled water contained in the volumetric flask. That is step 3. This 2.8 gram mass of potassium hydroxide you have weighed, you are expected to dissolve it in about 200 cubic centimeter of distilled water. Of course, the distilled water is going to be contained in that 500 cubic centimeter volumetric flask. Shake. Shake. Shake vigorously. So once you dissolve that mass in about 200 cubic centimeter of distilled water in the volumetric flask, you shake. You have to shake so that this 2.8 gram mass of potassium hydroxide will dissolve. All right? Step 4, which of course happens to be the last step. Make up the distilled water in the volumetric flask to the required mark. Now, like I stated in our previous class, in the case of how to prepare a standard solution of an acid, every volumetric flask has, a required mark. Please take a look at the volumetric flask showing on the screen. You see you have volumetric flasks of 500 cubic centimeter or 500 milliliter. You even have the one of 1000 milliliter. All these volumetric flasks are available in standard laboratories for you to use. Okay? So you are required to make up the volume of distilled water in the volumetric flask to the required mark. Remember, you dissolve the 2.8 gram mass of our potassium hydroxide in about 200 cubic centimeter distilled water in step 3. But you are meant to prepare, this solution of potassium hydroxide, this solution of base. You are meant to prepare it using 500 cubic centimeter volumetric flask. So you have to make up the distilled water now, from about 200 cubic centimeter to the required mark of 500 cubic centimeter. So when you make up the volume of distilled water to the required mark, shake again, shake again, shake vigorously. And then with this, you have prepared a 0.1 molar solution of potassium hydroxide. I hope this procedure is very clear. This is simply how you prepare standard solution of your base. You see this wonderful lesson, our dear friends, in 100 level, you need to know this because, of course, in your chemistry practical, you might be asked to describe how you can prepare a standard solution, and maybe a particular value is given to you, a concentration is given to you in a particular volume of volumetric flask. This is the procedure you follow. Is that okay? And our dear teachers, our chemistry teachers at O level, usually, like I said, you are being given hint, white paper by our exam bodies, WAEC, NECO, and you are required to prepare a standard solution, right? You are required to prepare a solution that your students will use for chemistry practical. Are you having challenges on how to prepare these solutions? You'll be given certain specifications as required by the exam body. This is the procedure you follow. And don't forget, of course, GMAETS 41 is always here to receive your request in case you have any challenge on how to go about preparing these solutions. Of course, GMAETS is here to help you out. So how many steps have been mentioned? 4 steps. The first is to calculate the mass of the base you require, are you following, to dissolve. Once you know the mass, the second step is to weigh out the mass using your weighing balance. The third step is to dissolve that mass in a certain volume of distilled water. And then, of course, the fourth step is to make up that volume of distilled water to the required mark according to the volumetric flask you're using. Don't forget to shake for homogeneous mixture. And like I always say, for complete ionization, this solution, this reagent is required to be prepared at least 24 hours, all right, to the day that the experiment is meant to be carried out. All right, just like an added information, remember that in this approach, this method that we've described, what we found out is that you are dissolving 2.8 grams, for example, in this case, 2.8 gram mass of potassium hydroxide in 500 cubic cm of distilled water of the solution. That is what really happens, because if you measure that 2.8 gram, like in this case, you dissolve it in that distilled water, make it up to the required mark, 500 as, the procedure required. If you come to the laboratory work now, to the exam hall, in this case, you're now to carry out the calculation following the questions that you might be asked. Did you know? With this information, one can get the mass concentration of the base directly. You know that mass concentration is equal to mass divided by volume multiplied by 1000 if the volume is in cm cube or in milliliter. Therefore, let me just tell you this for free as we conclude our class today, right? The mass concentration of this particular base now, from the information provided and what I have done so far or explained so far, the mass concentration is equal to the mass 2.8 divided by the volume of the flask 500, or we'll call it the volume of the solution. Are you following, right? Then multiplied by 1000. 2.8 divided by 500 times 1000. What will it be? Now let us find out. 2.8 divided by 500 and then multiplied by 1000. So this is going to give us 5.6 gram per dm cube. 5.6 gram per dm cube. So with respect to this particular solution, assuming that an examiner, are you following, prepared a solution using 2.8 gram of the base dissolved in 500 cubic centimeter of the solution, the mass concentration of the base is going to be 5.6 gram per dm cube or per liter in this particular case. And do you know, once you know your mass concentration and you know the name of the base, you can actually calculate the molar concentration. How about you find out, like in this particular case? Mind you, I've already explained how you prepare the solution. I've already explained it. This is just further information, that I am giving to you. Am I communicating? This is further information that I'm giving to you. My pen just fell. I had to pick it. So now that we know that the mass concentration is 5.6, how about I give you the information about, in this particular case, what would be the molar concentration? What would be the molarity of the base, potassium hydroxide in this case? What will be the concentration of potassium hydroxide in mole per dm cube? What will be the solubility? What will be the CA value? You need CA? No, what is going to be the CB? The CB value, because we're using B as a base. I know the mass concentration to be 5.6. So simply, the molarity, or the molar mass, or the concentration in mole per dm cube, or the solubility, or the CB, as you may choose to call it. Remember the formula is equal to mass concentration divided by molar mass. So let us find out. Mass concentration, right, is 5.6. And then we are dividing by what? Molar mass. It is potassium hydroxide that I used for this case study. Are you following, right? The molar mass of potassium hydroxide is 56. So if you have 5.6 divided by 56 here, we get 0.1. So do you see? It returned me back to the 0.1 molar value of that potassium hydroxide. And you know that in this case, you might not be given the molar concentration, you might not even be given the mass concentration. They will give you the statement in such a way that you can do the calculation yourself. So this is all about the procedure, and of course I've given you further information as per certain things you might have to calculate if you find yourself in the laboratory or in the exam hall. Share the link to this video to your friends, okay? And then encourage them to subscribe to this channel. Become a channel member on diamond level so you can access all the works on this channel, right? You may also choose to join the platinum level anyway. But remember, the higher the level you join, the more benefits you get. Are you in Unizik, Nnamdi Azikiwe University, Awka, and you need physical tutorials? Remember, GMAETS 41 runs physical tutorial on campus in Unizik. You can contact GMAETS 41 to get all the necessary information in order to join our classes. What courses do I take 100 level student? Math 101, Physics 101, Chem 101, Physics 107 practical, Chem 107 practical, Physics 103, Math 161. You will love it. I will make you believe, and your A's will be sure with first class in view. I'll see you in my next video.